After arranging the flower bed, Taher decides that the flower bed would look more attractive if one of the angles in the triangle were a right angle. He decides to place the right angle at vertex A, and he decides to leave the lengths of AB, the line segment AB, and the line segment AC at 4 and 5 feet respectively. To the nearest 0.1 foot, how long a piece of lumber would he need to replace the 6-foot piece represented by BC? Okay, so let's draw out exactly what he means. So first of all, Taher is referring to this angle right here, and he's saying he would rather it was a right angle. So what is a right angle? Well, that's a angle that's 90 degrees. A right angle is what you see on the side of a piece of paper. It also makes up a right triangle, a 90-degree angle, and that's what he wants instead of whatever angle is here right now. And so he also wants to leave the lengths of two pieces of lumber the same. So AB, and that's kind of nice because he won't have to cut again. Here is AB, and that's 4 feet long. And so he wants AB to still be 4 feet long here. We'll call this A, call this B. This should be 4 feet. And he wants AC to be the same length that it currently is as well. So AC here is 5 feet, and AC over here should also be 5 feet. The only thing he's changing so far is this angle. But there's one final thing that will need to change. Now BC will be a different length because here it has to fit this new dimension. And so our big question is, what is this length BC? And I'm going to go ahead and call that H. And the thing to recognize here is that this is a right triangle, and there's an important relationship in right triangles. That is, the hypotenuse, that is the angle across from the 90 degrees, is the square of the hypotenuse is equal to the sum of the squares of the two adjacent sides. And that specifically means in this case 4 squared, because that's one of the adjacent sides, plus 5 squared, which is the other of the adjacent sides. And this is just a basic formula that you're going to need to memorize that comes up in geometry quite a bit. It's the Pythagorean theorem. It's the sum of the squares of the sides of a right triangle equal to the square of the hypotenuse. So something to write down on your formula sheet and study the day before the exam if you don't remember it. But anyways, 4 squared is 16, and now this is just breaking down to a basic little arithmetic problem. 5 squared is 25, and so h squared is equal to 16 plus 25, and we can go ahead and add those two together. The total is 41, so h squared now is going to be equal to 41. We want to find the square root of both sides of this, so the square root of h squared is just going to be h. The square root of 41, and that's the side we're solving for. The square root of 41, let's get out our calculator. Well, that's the answer already, but 41 square root 6.4. 6.4, and that's the correct answer